Good morning, students. Today we will start with the solution of chapter number 9, that is areas of parallelogram and triangles. We had studied about the properties of parallelogram in chapter number 8 and the types of quadrilateral in chapter number 8. All the types of quadrilateral we had studied and all the properties we had studied of that types. Okay, now we will start with area. So areas of parallelogram and triangles. So here in this chapter we will deal with base and parallel lines. Okay, so here what is the areas of the figures which are between the same base and between the same parallel. Okay, the figure which are having the same base and which are between the same sets of parallel lines, they are having same areas. This is our whole chapter. Okay, so here first is exercise 9.1. so here it is, which of the following figures lies on the same base and between the same parallel? In such case, write the common base and two parallels. We have to write the common base and two parallel. Now see, if you will look to figure number, these are the questions for you. 1 2 3 4 5 and 6, total 6 figures are there. One by one we will solve all this. So when you will look to figure number 1, so figure number 1, we are having a parallelogram, that is AB parallel to CD, and a triangle. Triangle is on the same base of that parallelogram, that is on CD. So triangle and parallelogram both are having same base and they are between the same sets of parallel line, that is AB is parallel to CD. So you have to write, yes, it can be observed that trapezium ABCD and triangle PCD have a common base, that is CD, and these are lying between the same parallel lines AB and CD. Then come to the second figure. Second figure is having two parallelogram. First is PQRS and second is MNSR. But PQRS and MNSR both are having same base, but they are not having the same parallel sets. Okay, so here the answer will be no. It can be observed that parallelogram PQRS and trapezium MNRS have a common base RS. Okay, they are having a common base RS. However, their vertices, that is opposite to the common base PQ of parallelogram and MN of trapezium, are not lying on the same base. MN and PQ are not lying on the same line, so they are not between the same sets of parallel line. Okay, then after come to third figure. Third figure is again same as the figure number 1. We are having here same base, that is QR, and same sets of parallel lines, that is PS and QR. So answer is yes. It can be observed that parallelogram PQRS and triangle TQR have a common base QR and they are lying between the same parallel lines PS and QR. Then come to figure number 4. In figure number 4, you are not having same base, because for triangle you are having base as PQ and for parallelogram you are having base as whole BC. So here the bases are not same. So the answer is no. It can be observed that parallelogram ABCD and triangle PQR are lying between same parallel lines AD and BC. However, these do not have any common base. Okay, they are not having any common base. For triangle the base is PQ and for parallelogram the base is BC. Now come to question number 5. Question number 5 is this figure we are having. So in this figure you are having same sets of parallel lines and same base. So the answer is yes. It can be observed that parallelogram ABCD and parallelogram APQD have a common base, that is AD, and these are lying between the same parallel lines AD and BQ. Okay, then come to figure number 6. Figure number 6 is again no. It can be observed that parallelogram PBCS and PQRS are lying on the same base PS, but however these do not lie between the same sets of parallel lines, so they are not parallel, means their lines are not parallel. Now next is exercise 9.2. so question number 1 is, in the given figure ABCD is a parallelogram, AE is perpendicular to DC and CF is perpendicular to AD. If AB is equals to 16 cm, AE is equals to 8 cm, CF is equals to 10 cm, find AD. You have to find AD. So here you know that the given figure is a figure of a parallelogram. So if one side is 16, that is here it is given AB is equals to 16, so the other side means the side opposite to that side, that means AB and CD both will be equals to 16 cm because that are the opposite sides of parallelogram. Okay, so they will be equal. So 16 and AB is 16, so CD also 16. Now you know that the area of parallelogram, what is the area of a parallelogram? That is base into height. Okay, so area of parallelogram is base into height or altitude also you can say. So area of parallelogram ABCD, if we will talk about, then it will be, if you are taking base as CD, so your height will be AE. That will be equals to, if you are taking base as AD, so your height will be CF. Okay, so these two are the base into height, that is formula of a parallelogram. Now whatever the values you are having, substitute that values. So we are having CD we are having, that is 16, into AE we are having, AE is how much? AE is 8, that is equals to AD we are not having, we have to find AD, so as it is, and CF is 10. Now if you want to find AD, so keep AD as it is and bring this 10 to the left hand side, so it will be in division. 16 8 is 128 divided by 10, that is equals to AD. So your AD will be equals to 12.8 centimeter. This way you will get your answer of AD. Only this much is your sum. Next sum, question number 2. Question number 2 is, if E, F, G and H are respectively the midpoints of sides of a parallelogram ABCD, show that EFGH is equals to half of area of ABCD. Now you have to first of all make a parallelogram ABCD, then after you have to write the midpoints, that is E, F, G and H, then after join the midpoints E to F, F to G, G to H and H to E. Then after make a line segment, connect H to F. Okay, so let us join HF. First of all you have to join HF, then in parallelogram ABCD. Now see, if the given figure is a figure of a parallelogram, then you know that opposite sides will be equal and parallel. So if we are talking about ABCD, then AB will be equal to CD and AB will be parallel to CD. In the same way, AD will be equals to BC and AD will be parallel to BC. Opposite sides will be parallel and equal. So here they had written AD is equals to BC and AD is parallel to BC. Okay, AD and BC are equal also and parallel also, because the reason is opposite side of a parallelogram are equal and parallel. Then after, AB and CD are also parallel and equal. So AB is equals to CD, opposite side of a parallelogram are equal. But if we are doing half of this AD and we are doing half of BC, okay, so half of AD will be AH and DH and half of BC will be BF and CF. Okay, so they had written here AH is equals to BI. What they had taken? They had taken the above this much parallelogram. Okay, so here AH will be equals to BF and AH, if it is equal then it is parallel also, because opposite side of a parallelogram, if the whole is equal, the part is also equal. Okay, so AH will be equals to BF because H and F are the midpoints of AD and BC. So therefore, now if the opposite sides are equal and parallel, so therefore we can say that ABFH is a parallelogram. Now if this is a parallelogram, then consider only ABFH. A, B, F and H. In this we are having a triangle, that is triangle HEF. Okay, this much. So this triangle is on the same base, that is HF, and between the same parallel lines, that is AB and HF. So what will be now? The result will be areas of these two will be equal. So area of triangle HEF, this will be equals to area of parallelogram ABFH. Okay, these two areas will be equal. Now same way, this will be your result number 1. So this is your result number 1. Okay, now same way here you will have half. Why half? Because this is the whole parallelogram and you are having half of the parallelogram, so we have to write half of area of ABFH. Okay, because H and F are the midpoints. Then after, same way, if we are talking about the below parallelogram, okay, below means I am making it for you. Again you are having one parallelogram, that is HFCD, and in this you are having the triangle FGH. Okay, so this is the triangle. Now again this triangle and parallelogram are on the same base, that is HF, and they are between the same sets of parallel lines HF and CD. So again the areas will be equal. So areas of HGF is equals to half of area of HDFC. Now why this is half of the area of HDCF? So because again H and F are the midpoints and these are the half parallelograms from ABCD. Okay, so that is equals to half. Now this is result number 1 and this is result number 2. Now if you will add both these results, so what you will get? When you will add both this result, so how you have to add left hand side on left hand side and right hand side on right hand side. So this is the left hand side and this is the left hand side. So you have to add area of EFG. So this is your area plus area of HGF. So this is your area. When you will add both this, you will get area of EFGH. You will get this thing, that is equals to, now on the right hand side you are having half of area of ABFH plus half of area of HDCF. Okay, now this half and half common in both, so we will take common. So that is equals to, half is common. Now inside is left area of ABFH plus area of HDCF. Okay, now when you will add both these areas of HDCF and areas of ABFH. So see, ABFH plus HDCF. When you will add all this, you will get half is outside, so half as it is, and when you will add both these parallelograms, you will get the whole parallelogram, that is half of area of ABCD. So your ultimate answer is both these triangles addition, that is EFGH. So area of EFGH will be equals to half of area of ABCD. So this is your final answer. Next is question number 3. P and Q are 2 points lying on the sides CD and AD respectively of a parallelogram ABCD. Show that area of APB is equals to area of BQC. Okay, now you have to show this, that these two triangles are equal in area, that is APB is equals to BQC. So directly you can start with, it can be observed that BQC and parallelogram ABCD lie on the same base and between the same sets of parallel lines AD and BC. So both the areas will be equal. So area of BQC will be equals to half of area of ABCD. Okay, BQC will be equals to half of area of ABCD. Now similarly for triangle APB is equals to triangle APB and parallelogram ABCD lie on the same base AB and between the same parallel lines AB and CD. So again you are having the same sets of region over here. So this two will be your region. Now from equation number 1 and 2. Now from equation number 1 and 2, what we are concluding, that this is same and this is also same. So we can conclude that this area of triangle BQC will be also same to area of triangle APB because both the values are same. So only this much is your sum. Okay, so it is done. Next is question number 4. In the given figure, P is a point in the interior of a parallelogram ABCD. Okay, in the given figure, P is the point in the interior of a parallelogram ABCD. Now show that area of APB plus PCD is equals to half of ABCD, and area of APD plus area of PBC is equals to area of APB plus area of PCD. Hint is given to you. Through P, draw a line parallel to AB. You have to draw a line which is parallel to AB through P. Now this is for your hint. Okay, now for first question, For first question, let us draw a line segment EF passing through point P and parallel to a line segment AB. First question you will prove this. Let us draw a line segment EF passing through a point P and parallel to a line segment AB. Now in parallelogram ABCD. Now if we talk about parallelogram ABCD, so there AB is parallel to EF by construction. Okay, AB is parallel to EF by construction. Then after ABCD is a parallelogram. That you know that ABCD is a parallelogram. Now, if it is a parallelogram, so your opposite sides will be equal and parallel. So here AD will be parallel to BC. Okay, so here AE will be parallel to BF. Okay, AE will be parallel to BF, because if it is a parallelogram, so you can write opposite sides are equal and parallel. Now from equation number 1 and 2. Now if you will see equation number 1 and 2, so you will have AB is parallel to EF and AE is parallel to BF. So therefore quadrilateral ABFE is a parallelogram because opposite sides are equal and parallel. So this given figure is a figure of a parallelogram. Now it can be observed that triangle APB. Now if you will observe triangle APB and parallelogram ABFE, they are on the same base and between the same parallel, that is AB and EF. Okay, so they are equal in area. So we can write area of triangle APB, that will be equal to what? Half of area of ABFE. Okay, if you are having a parallelogram and a triangle, then you have to write that the triangle is half of the area of parallelogram. So this is half of ABFE. Now similarly for triangle PCD and parallelogram EFCD. Now if you will look for triangle PCD and parallelogram EFCD, so again you will have same thing, that is area of triangle PCD, that will be equals to half of area of triangle EFCD. Now if you will add all these two equations, so when you will add area of triangle APB with area of triangle PCD, okay, so see now area of triangle APB plus area of triangle PCD, when you will add, you will get half of area of ABFE, this is equation number 3, plus area of EFCD, and here the half and half, it is in both, so we are taken out common. Okay, so area of triangle APB plus area of triangle PCD is equals to half of half is common in both, so it is outside only, and area of ABFE plus area of EFCD. Now you have to prove ABFE plus EFCD. So see ABFE, I am marking it out. ABFE, that is the above parallelogram, and this is ABFE, and the below parallelogram is this. Okay, so when you will add both this parallelogram, you will get the total, that is ABCD. So here they had written area of triangle APB plus area of triangle PCD is equals to half of area of ABCD. So this is your one proof. Okay, then after question number 2. So question number 2 is area of APD plus area of PBC, that is equals to area of APB plus area of PCD. So now see again this figure. So let us draw a line segment MN passing through point P. Now you have to draw a line segment MN which is passing through point P and parallel to line segment AD. Now this MN will be parallel to AD. Now in parallelogram ABCD, again MN will be parallel to AD, okay, by construction. So this is the first reason. Then after give this as result number 6. Then after ABCD is a parallelogram, so we know that AB will be parallel to CD, opposite side of a parallelogram. Now AM will be parallel to DN also. Okay, AM, if because opposite sides of a parallelogram it is, so give this as result number 6 and this as result number 7. Now from 6 and 7 what you conclude? You conclude that MN is parallel to AD and AM is parallel to DN. If these two are the condition, then therefore the given quadrilateral is a parallelogram because opposite sides are parallel. So it can be observed that triangle APD and parallelogram AM and D. Now see triangle APD and parallelogram AM and D. I am marking it out. This is triangle and this is the parallelogram. So this triangle and parallelogram, I am making it over here so that you will not have confusion. Here we are having M A M N D, and here we are having point P. So this way it is. Okay, so now these are between the same base and on the same sets of parallel line. So both the areas will be equal. So you can write area of triangle APD, that is equals to half of area of AM and D. Now similarly you will see for PCB also. PCB is this triangle and it is between this. Okay, so again same sets of parallel line and same base, common base. Okay, so so you can write area of triangle PCB is equals to half of MNCB. Okay, now when you will add both area of triangle PCB and area of triangle APD, when you will add both, so you will have again half and half will get common, so common outside. Then area of triangle AMND plus area of triangle MNCB. Now if you look for AMND is this much, plus if you will go for MBCN, so this is this much. Okay, so when you will add both, you will have ABCD. So again area of triangle APD plus area of triangle PCB is equals to half of ABCD. So this is your second reason. Now you want third one. So third one is area of triangle APD plus area of triangle PBC, that is equals to area of triangle APB plus area of triangle PCD. So when you will compare both the equations, that is equation number 5 and equation number 10, when you will compare, both are having the same values, that is half of area of ABCD. So they both are same. So you can write it directly, area of triangle APD plus area of triangle PCB that is equals to area of triangle APB plus area of triangle PCD. Now come to question number 5. Question number 5 is, in the given figure PQRS and ABRS are parallelograms and X is any point on side BR, show that these two are equal. Okay, so this is the same way you have to work. Okay, now see, you have to do in the same way as we had done in question number 4. So it can be observed that the parallelogram PQRS and ABRS lie on the same base SR and also lie in between the same parallel lines SR and PB. Okay, they are between the same sets of parallel line, that is SR and PB. So the areas will be equal. So both this parallelogram will have equal area, that is area of PQRS will be equals to area of ABRS, because both are the parallelogram, they lie between the same sets of parallel line and on the same base, so equal in areas. Then after question number 2, area of AXS and is equals to half of PQRS, because they lie on the same base and on between the same parallel, but if it is a triangle then you have to take half of PQRS. So area of triangle AXS, that is equals to half of ABRS. This is equation number 2. So from 1 and 2, what you can write? From 1 and 2 you can write area of triangle AXS is equals to half of area of PQRS. Now, a farmer was having a field in the form of a parallelogram PQRS. She took any point A on RS and joined it to point P and Q. In how many parts are the field is divided? What are the shapes of these parts? The farmer wants to show width and pulses in equal portion of the field separately. How should she do it? Okay, so this is your figure. Now from the figure it can be observed that point A divides the field into 3 parts. Point A is dividing the field into 3 parts. These parts are triangular in shape, that is triangle. First triangle is triangle PSA, second is triangle PAQ, and third is triangle QRA. Okay, now when you will add all these 3 triangles, you will get one parallelogram. So area of triangle PSA plus area of triangle PAQ plus area of triangle QRA, that will be equals to area of parallelogram PQRS when you will add all this. Okay, now when you will see PAQ triangle, if you will see triangle PAQ, so triangle PAQ is between the same sets of parallel lines and on the same base. Okay, so area will be half. So PAQ is equals to half of PQRS. PAQ will be half of PQRS. Now from equation number 1 and 2, this is equation number 1 and this is equation number 2. From equation number 1 and 2, what can you say about? So area of PSA plus QRA will be equals to what? Will be equals to half of PQRS. Okay, from 1 and 2 we can say this, because PAQ is equals to half of area of PQRS, so this 2 also will be equals to half of area of PQRS, because all these are equal to area of parallelogram PQRS. So clearly it can be observed that the farmer must sow wheat in triangular part PAQ and pulses in other two triangular parts PSA and QRA, or wheat in triangular part PSA and QRA and pulses in triangular part PAQ. Okay, either the farmer can choose the option if she wants to sow wheat in one part or pulses in two parts. So this is exercise 9.2.